So next, negative mesomeric effect. So here, negative mesomeric effect, groups which decreases the electron density in rest of the molecules said to have negative mesomeric effect. So here, transfer of electrons takes place towards the atom, which is in conjugation with the whole chain. Okay. So towards the atom or group. Okay, which is in conjugation. So that's why electron density in the rest of the molecule decreases. Okay. So in conjugation, for example, propanol is there. This is aldehyde group. CHO is the aldehyde functional group. Okay. So here transfer of electrons takes place towards the group. Okay. So when electrons transfers towards the group, automatically in the rest of the chain, electron density gradually decreases. Okay. So that's why plus charge over rest of the molecule. And electron density over the group increases. That's why minus charge over oxygen, which is present in aldehyde group. Okay. So that is negative mesomeric effect. Okay. So all these molecules, they shows the negative mesomeric effect. Nitro group, aldehyde, carboxylic acid, sulfonic acid, amide group. Okay. So all these shows the negative mesomeric effect. And also compounds, for example, if you take halogens. Okay. Halogens generally shows negative inductive effect. Okay. Halogens shows minus I effect. Okay. But halogens, all the halogens have lone pair of electrons. Okay. So due to the presence of lone pair of electrons, they shows positive mesomeric effect. Okay. Just now told in vinyl chloride. Okay. So halogen shows plus M effect. Positive mesomeric effect because they are having lone pair of electron and transfer of electrons takes place rest of the chain, away from the atom and rest of the chain. That's why electron density increases in rest of the chain. In case of positive mesomeric effect, decreases in the rest of the chain. In case of negative mesomeric effect. Okay. Next, coming to resonance. Next, resonance, concept of resonance and resonance effect. Okay. So resonance. So first let us see the definition of resonance first. If a molecular ion which can be shown by two or more structures. Okay, molecular ion that may be represented with two or more structures differing only in the distribution of electrons. So in the distribution of electrons means position of the bonds. Okay, differing only in the distribution of electrons. But none of these structures truly explain all the properties of that molecule or ion. Okay. None of these structures, they can explain all the properties of molecular ion. Okay. So such type of structures are called as resonating structures or canonical structures. And this phenomena is called as resonance. Okay. So a molecular ion that exists in one or more structures. For example, benzene is there. Benzene exists in two structures, two canonical forms. Okay, these are the benzene different structures. Okay, so molecular ion can be shown by two or more structures. So differing only in the distribution of electrons. So here pi electron distribution is different in these two structures. For example, number 1 and number 2. Okay. And none of these structures completely explains the properties of benzene. Okay. So that's why this type of structures, these are called as canonical structures or resonating structures. So benzene shows phenomena of resonance. Okay. For example, if you consider resonating structures of urea. So urea exists in three different resonating structures. So to explain the properties of urea, Okay? We have to take all these three resonating structures in consideration. Okay? And the real structure of molecule is not possible. Okay? Why? Because it is only a hypothetical structure which is known as resonance hybrid. Okay? So, to explain properties of urea, we consider these three resonating structures. Okay? But actual molecule that is called that is a hypothetical structure, and that is called as resonance hybrid. Resonance hybrid. So this is a hypothetical structure. Okay? So urea exists in three different forms, but none of these structures completely explain the properties of urea. Okay? So these three structures collectively explains total properties of urea. So why? Because the real structure is not possible for that. Why? Because that is a hypothetical structure which is known as resonance hybrid. Next, coming to resonance energy. So here it is the energy difference between actual energy of molecule and more stable canonical forms. Okay, difference between actual energy of a molecule and more stable form of one of the canonical forms, that is called as resonance energy. Okay, next coming to resonance effect. Resonance effect. So resonance effect. So which is indicated with R. So resonance effect is polarity produced in a molecule by the interaction of two pi bonds or one pi bond and a lone pair of electron present on adjacent atoms. Okay. So polarity produced in a molecule by the interaction of two pi bonds or one pi bond and lone pair of electrons. Present on adjacent atoms. Okay. So this is resonance. Polarity produced in a molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons which are present on adjacent atoms, indicated with R. So here both the resonance effect and mesomeric effect, they appear the same, but both are different. Okay, resonance effect, mesomeric effect appear like the same effects, but both are different. Why? Because resonance effect involves pi electrons and sometimes sigma electrons also. But mesomeric effect that involves only pi electrons and lone pair of electrons in the conjugative system. So that is the difference here. Okay, both appear same but different, because resonance effect involves pi electrons and even sigma electrons also, whereas mesomeric effect that involves pi electrons and lone pair of electrons. Okay, so like mesomeric effect, here resonance effect is also in two types. Okay, positive resonance effect, plus R effect, and minus R effect. Okay, so coming to plus R effect. So like mesomeric effect, here in plus R effect, transfer of electrons takes place away from the atom. Okay, attached to conjugate system. Transfer of electrons takes place away from the atom attached to conjugate system. So transfer of electrons takes place away from the atom. That's why electron density throughout the chain increases. Okay, same as mesomeric effect. Okay, then coming to positive resonance effect. Here examples are halogens, OH group, okay, OR group, NH2 group, okay, so etc. Next, minus R effect. Transfer of electrons takes place towards the atom attached to conjugate system. Transfer of electrons takes place towards atom or group attached to conjugate system. Okay, so with this electron density increases on the group. Okay, so for example COOH, okay, NO2, CHO, etc. Just like same like mesomeric effect, negative mesomeric effect.